Good morning, everyone, and welcome to our very first stop on the Cloud Security Treasure Map webinar series, the Agent Abyss, to dive or not to dive. Today is the Agent versus Agentless Detection in Cloud Security webinar. So hi, I'm Emily from Core to Cloud, and I'll be your host for the opening part of today's session. It's fantastic to see so many of you joining us as we kick off this five-part series, Navigating the Cloud, 5 Stops to Security Gold. So over the coming sessions, we'll be charting the course through some of the most pressing challenges in cloud security, each one designed to give you clarity, practical guidance, and a strategy you can take back to your own organization. Today, we're diving straight into the agent abyss, exploring one of the most debated decisions in cloud detection, whether to deploy agent-based tools, agentless approaches, or a mix of the two. So Tom, if I could ask you to go to the next slide, please. Thank you very much. So for those that don't know who we are, I work at Core to Cloud, and we're an MSSP based in Cirencester. We're well renowned in the UK for bringing some of the most innovative and effective cybersecurity technologies to the UK and working with some of the best ones available while providing our own services to ensure that businesses remain secure and protected. So our focus is giving organizations clarity, confidence, and the resilience in the constantly evolving threat landscape. But I suppose that's enough from me. So I'm delighted to hand over to Tom Paul from Orca Security. Tom will be leading today's session, introducing Orca and guiding you through the depths of the agent abyss. So Tom, over to you.
Thank you very much. What an introduction. Hi everyone, and thanks for joining today. My name's Tom Poole, and I'm from Orca Security. Genuinely excited to dig into a topic that's caused quite a stir in our industry for a while, and that's agentless versus agent security. And we'll explore why this matters, look at the strengths and limitations of both approaches, and see how innovative technologies like Orca have fundamentally changed the game. So to start with, we'll examine just some high-profile incidents that we can learn from to help understand this kind of debate. And then we'll explore agent-based security, its challenges, before diving into agentless approaches. I'll show you Orca's solution. We'll have a live demo, and then we'll look at how runtime security fits into the picture. And then finally, we'll wrap up, address some questions, and discuss the next steps. So I hope that sounds good, and we can get started. So just before I kick off, what is your biggest operational challenge with security agents? I talk to organizations every day, and almost every single one has one of these challenges when they're using traditional agent-based solutions and trying to, or have taken those solutions into the cloud. Just bear this in mind as we go through the presentation. I'd like to kick off with a story that many of you probably experienced firsthand. If you cast your mind back to July 19th last year, major airlines were grounded worldwide. Hospitals, doctors in the UK couldn't access patient data. Banks were unable to process transactions. Windows systems were suddenly displaying the blue screen of death, and chaos essentially ensued across nearly every industry. And this wasn't some sophisticated cyber attack. Oh, it was a faulty update to CrowdStrike's Falcon security agent. The scale was staggering. I think 8.5 million devices were assumed to be affected worldwide, and it caused an estimated 4.3 billion in economic damage. And all of that was from a security tool that was meant to protect systems and not crash them. And I think this incident highlighted a fundamental risk with agent-based security. When your security solution runs with elevated privileges and it's running on critical systems, a single mistake can have huge consequences. Operational issues aren't the only concern, though. If you cast your mind back to another incident, SolarWinds in 2020, attackers compromised their build system and inserted malicious code into legitimate updates for the Orion platform. Again, the scale was huge. I think around 18,000 organizations actually installed these compromised updates, and that gave attackers persistent access to networks for nearly 9 months. Now, These two incidents represent different but equally concerning risk: operational fragility and also security vulnerability. Both stem from fundamental architecture of agent-based solutions. So if we take a step back and we look at what and we think about what security agents are, now they're software components installed directly onto the systems that they protect. They run with elevated privileges to monitor things like system activity, enforce security policies, and then typically report back to a central management console. Now, this model made perfect sense in the era of on premises infrastructure, where change was slow and controlled. As organizations have shifted to dynamic cloud environments, the limitations of this approach have become increasingly apparent. And to really understand these challenges, um, we need to understand what was being used or how it was being used to secure our data center. So, from a timeline perspective, we first had agents. Agents are installed and maintained as other applications running alongside the workload, reporting back any rogue or unsuspecting activity that is occurring within the application or machine. Another approach that has been used in the past is the network scan. Network scanners probing resources externally, looking for known configuration errors. And these two solutions have been the cornerstone of data center security for many years. If you wanted to understand your physical security posture, you were typically using one or both of these techniques. And in fact, many organizations still use these techniques today, even in a very modern public cloud environment. Where agents used to run on physical machines, they're now running on virtual machines, and scanners are being deployed as appliances in virtual networks. And then over kind of the last 5 or 6 years, a third category of security for the cloud was created called CSPM, or Cloud Security Posture Managers. Now, their purpose is to monitor the cloud configuration itself. And CSPMs are designed to connect the cloud infrastructure and analyze data about the cloud assets, the networks they belong to, user permissions, but they must rely on agent-based solutions to actually see inside those assets or understand what is actually going on inside the workload, the virtual machine, the container. Now, CSPMs were introduced with good intentions as solutions that read cloud metadata to identify those misconfigurations and other infrastructure or asset problems in the cloud. However, they really only add a new layer of coverage. They don't encompass any of the previously mentioned capabilities that we get from agent-based security. If the agent approach has been the traditional model for security monitoring and enforcement for decades, way predating the cloud era, then what's the problem? Why can't we use agents in the cloud? Well, they bring several challenges. And first and foremost, something that, again, I see and talk about every day with organizations, ensuring that an agent is installed on every cloud resource is a massive challenge, especially when resources are constantly being created and destroyed, right? Ephemeral workloads. Then there's things like the maintenance overhead, the performance impact, and the cost. Every minute, every second of resource that you use in the cloud has a cost associated with it. And then there's things like disruptive updates, as we mentioned from the incidents earlier. Even if we consider performance impact alone, security agents typically consume 5 to 15% CPU resources and up to 500 megabytes of memory per agent. And many organizations actually run multiple agents, which then compounds that impact. If I give you a quick example, we worked with a financial services firm, and they were running agents across 5,000 cloud instances. They had an average CPU overhead of around 8%, and that amounted to an annual cloud compute spend of 730,000. They were effectively burning nearly 60K a year just on the resource overhead from their security agent. They also had a vulnerability agent. So the true TCO for that was effectively double. And it may seem like a small amount of resource, but in the cloud, when you start to scale that out, it can have a big impact on cost. And most organizations are actually unaware and haven't calculated that true cost. Beyond the performance impact, there's maintenance. A recent survey actually found that 58% of security teams report agent management as one of their most significant burdens. And then we also have supply chain risks, right? As we saw with the SolarWinds attack. If attackers compromise your security agent, they potentially gain access to all your agent protected systems. And that's a dream scenario from an attacker's perspective. Finally, there's the issue of coverage gaps. Again, in that dynamic cloud environment, resources are often created without agents, either by mistake or to avoid performance issues. You may even have assets in the cloud that don't support the deployment of your traditional agent. Things like AWS Lambda or Azure Functions, serverless compute. So what's the alternative? Agentless security takes a fundamentally different approach. Instead of stalling software on each endpoint, it collects and analyzes security data from outside of the systems it protects. And that typically involves, using cloud provider APIs. Analysis then happens in a centralized location, completely separate from those protected systems. Agentless security has a number of benefits. Deployment is rapid. It's just a matter of deploying a role in your cloud provider, and coverage is pretty much immediate. There's zero performance impact since no code runs on protected systems. Coverage is complete, including systems that might be missed by agent-based approaches. And there's zero maintenance since there's no agents to update. The attack surface is essentially reduced, again, because there's no agent that could be compromised. Gartner actually said that by the end of this year, 2025, 60% of organizations will probably be using agentless scanning for vulnerability management. And that represents a significant industry shift. To give you another quick example from a recent customer of mine, they were a major retailer managing over 12,000 cloud workloads. They switched to Orca for agentless approach in the cloud, and they managed to achieve 100% visibility of all of their assets in less than a day. They reduced their security cost by around 48% and also eliminated stability issues that they had been having. It was affecting availability of some of their critical services. Perhaps most significantly, though, they discovered 1,500 previously unknown workloads that had been operating without any security monitoring across development environments, testing environments, and things like that. That represented a substantial blind spot within their security posture. Here's the thing, though. Not all agentless solutions are created equal. The depth of visibility you get varies significantly between different approaches, between different vendors in the market. Some rely solely on cloud provider APIs, which then offer limited visibility into the workload itself. Others, like us at Orca Security, use a more sophisticated technique to gain deeper insights without deploying any agents. So the contextual awareness and detection capabilities differ significantly across these different agentless solutions. At Orca, we actually pioneered a unique approach called side scanning. And unlike API-only solutions, side scanning essentially does deep workload inspection. It doesn't require an agent. It actually works by taking a read-only snapshot of your workload's block storage, and then we reconstruct the operating system, the applications, and data from that snapshot so that we can scan for vulnerabilities, misconfigurations, malware, even suspicious commands in like the bash history. This gives us comprehensive visibility across your cloud estate without the operational overhead or security risk of agents. And it's okay me saying we've got this great technology, but let's actually jump into the demo environment and I can show you what that agentless visibility looks like. So the first thing to know about Orca and Agentless is deployment. It's a huge benefit when it comes to deploying in the cloud because we're leveraging the cloud provider's APIs. We only need a role, predominantly read only, within that cloud provider. A deployment typically takes 15 minutes per cloud provider. So maybe 15 minutes for Azure, 15 minutes for AWS. And once we have that deployed, it takes 24 hours and we will have a full inventory of all of the assets that exist across your public cloud. And that could be AWS, GCP, Azure, Oracle Cloud, or Ali Cloud. It could be everything from containers to serverless, virtual instances, buckets, databases, identities, Kubernetes, everything that exists within that cloud environment. You can see all of the assets and we can filter those assets down. If I just wanted to see my AWS assets, I can. If I wanted to just see my public facing assets, what is exposed across my cloud environment, again, I have the ability to do that. And I have all of this information within 24 hours of deploying the technology. If we look at these assets, you'll see that every asset has a risk score. They have alerts. Some have what we call attack paths, essentially where we've identified an entry point and a way to move laterally to something business impacting using this particular asset. So how did we get there? Well, if I just take a virtual instance as an example, and everything that you see here is achieved using agentless technology, right? The first thing that we have is just a dynamic description. We can see that this instance is running. It was created 2 years ago. It's publicly accessible. It's running Ubuntu 16.04, which reached end of support. We identified thousands of vulnerabilities. We identified application endpoints. We can see the asset is exposed to the internet through this security group. We can see the rules, so the port range, the IP addresses. We can see the users, the roles that have entitlements across this asset. We have a comprehensive amount of information. Its compute details, what image it's using, volumes are attached, all of its networking configuration, even to understanding what local ports are listening on the operating system, the IAM policies that are attached, the applications that are installed, the packages, the licenses that it's consuming, and the running services at the time we identified this asset. We can go as far as the SSH config file, right? Or the bash history. We have a lot of depth to the data we're able to get about an asset simply through our agentless approach. Once we understand the asset in detail and we understand the cloud environment it exists in, we have all the context. And then we look to identify risk associated with those assets. And that could be vulnerabilities, that could be understanding its blast radius, identifying if it holds sensitive data, things like AWS access keys or unencrypted SSH keys. We can look for malicious files. We have both signature-based and heuristic detection. And again, it's happening out of band. It's happening against a snapshot of the asset. So there's no performance impact to the production workload. Suspicious activity, that could be from the bash history, that could be just evaluating the audit trail within the cloud provider and understanding if there are anomalous or malicious behaviors occurring from those events. Ultimately, we do this for every single asset across your cloud provider. We don't need to know it exists. We find everything because we're leveraging those APIs, and then we generate alerts for the risk we find. Now, if you're like any security team or most organizations that I talk to, when I mention alerts, there's this kind of sigh, not more alerts. You know, we have so many critical alerts that actually nothing is critical. We don't really know how to prioritize. Um, and that's probably the second biggest thing that Orca provides in terms of value to its customers. We don't just generate alerts and say that everything is critical. We actually use the context that we have, all of that rich information about the cloud environment, about the workload to help you prioritize risk. If we take a vulnerability as a great example, and I'll use Log4j because most people know Log4j. It has this CVE has a high CVSS score. We can see it's a 10. But we know that just because the vendor says that a vulnerability is critical, it doesn't mean it's critical to your environment, to the way that your assets are configured. And that's really important because we don't want to spend time fixing things that don't actually improve our security posture because most teams have too much to fix. We have to prioritize, we have to reduce the risk in the most efficient way. If we look at our score breakdown, why have we determined that this particular vulnerability on this particular asset in this particular cloud account is a 9.6? It's a critical risk. We've actually used 14 different factors across both impact and probability, a mixture of both risk-based and asset-based context. So yes, we've considered the CVSS score, and that has a high contribution to the priority. But we've also leveraged things like EPSS, data-driven intelligence. What's the likelihood that this will be exploited? Is it being exploited in the wild? What's the exposure of the asset? Here it's public facing. So again, it has a strong contribution to the fact that this is critical because it's publicly accessible, it's exploitable, and it is being actively exploited. The state of the asset is also running. And that's important because we're talking about the cloud where things often start and stop. Is it running right now? Can it be exploited? Then there's other factors like the risk profile. Does it have other vulnerabilities with exploits? Does it hold sensitive data? Is it associated with a tap pass? Are there ways to move laterally from this asset to something else within our environment that could cause a business impact? All of these factors together tell us that actually this vulnerability on this asset in this cloud environment is a critical risk. We could have that same vulnerability on a different asset in a different cloud provider, maybe, a VM in AWS, but it isn't publicly exposed. It doesn't have any sensitive data. That might be a high or a medium risk. It's not something we need to prioritize right now. And that's really important. A customer recently said to me, Orca is like their to-do list. They wake up in the morning, get ready for work, sit down, open Orca, and they immediately know what they need to go and start addressing. In terms of the different types of risk that we can see, again, all of this is powered through our agentless capability. We have access control, authentication, data at risk, malicious activity, misconfigurations, vulnerabilities. There's a lot that we can see across the cloud environment, lots of different types of risk. And again, you get this visibility pretty much immediately. There's no long-term deployment that you need to go through. It's all out of the box. Another big part of the value we deliver is then using all of that context, all of the information we know about the environment and about the different risks that exist to understand attack paths in your environment. Attack paths in Orca start with an entry point. So some way for a malicious actor to gain entry into the environment. They typically include lateral movement, So moving from that entry point to something that we would consider is business impacting. And that's really important because attack paths essentially give you the view of business risk. A business impacting asset might be a storage account with PII or a database that contains sensitive customer information or proprietary data. It could even be an overly permissive user or role within the environment that can affect change. We can technically identify those, we call them crown jewels. And then our customers can also identify their own crown jewels where they have the business context. Perhaps this particular container is part of a critical service, critical function. That's a crown jewel. The attack paths always lead to those crown jewels. If I give you an example, let's use this example in AWS. I have my API security demo account. And within that AWS account, there's an Nginx dev server. It looks like this is just an EC2, but it's publicly exposed. And we've actually identified a service vulnerability on that instance. In this case, it's in SSH. Now, when we look at that vulnerability, it's actually got a score of 8. It's a high risk. It's something that needs to be addressed, but it's not something that you would typically ask your team, maybe your engineering team, to drop everything and go and fix immediately. It might be part of your SLA process, your remediation process, might get logged as a Jira ticket, and it'll be addressed at some point in the future. However, what we also identified on the file system of this instance are some AWS keys, so sensitive keys on the file system. And we actually do a validity check on keys as well. So we can determine that these keys are valid for this particular user and can be leveraged for this user, Anika. And Anika has an S3 read-only access policy applied. And that's an overly permissive policy in AWS where that user can essentially read data on any S3 bucket within this Acme production account. So if we think about this step by step, we have our initial access point, right? The service vulnerability on a public-facing asset is our initial access. AWS keys on the file system allow that lateral movement. And this overly permissive policy against the user, if that user is compromised with those AWS keys, the malicious actor can read data from our S3 bucket where we've identified it as a crown jewel. It's holding some form of sensitive data. We don't want that to fall into the attacker's hands. I'm able to see this because of that visibility Orca has provided across various aspects of the cloud environment and correlating all of that context, all of that risk together. I hope that makes sense and you can see the value. I have conversations with customers every day about our attack paths and bringing that insight to them. It always gets the strongest reaction. It's one of my favorite things to show during our risk assessments and proof of values. Now, if we jump back into our slides here, if agentless security then can provide that level of context, do we need agents at all? I think that's a fair question. And again, it's one that I hear often. And there is one gap, and that's runtime security. Detecting and responding to threats in real time, right? Agentless approaches provide point-in-time visibility, but they may miss activities at the runtime. For high-risk assets, that real-time visibility can be critical. But traditional agents aren't the only option. There are several distinct challenges that we need to be able to solve that require active threat detection and response. We've got to be able to monitor processes as they execute, analyze memory for signs of exploitation, track network activity in real time, and then be able to enforce security policies as events occur. And traditionally, these capabilities have required agents running directly on the operating system being protected. And that approach brings all those risks and challenges that we discussed right at the start of this webinar. So let me introduce eBPF, Extended Berkeley Packet Filter. If you've not heard of it, it's a technology that runs sandbox programs in the Linux kernel. It provides deep visibility into system activities, and it has a remarkably low overhead. It was actually developed for network packet filtering, but then it evolved into a tool for system observability and security. eBPF programs actually run in a restricted environment within the kernel, so it has strict verification to ensure that they can't crash the system or compromise its security. It makes them a lot safer than traditional agents that were installed within the operating system. Something to look at as well is the benchmark data that compares traditional agents with eBPF on identical workloads. Traditional agents consumed around 8.7% of CPU resources on average, while eBPF sensors used just 0.6. That's a 14x reduction in overhead. Similar story for memory usage. Agents required on average 385 megabytes of RAM, and that compared to just 24 megabytes for sensors. Again, it's around a 16x reduction. Similar story for I/O operations as well. Interestingly, over a 30-day benchmark period, systems with traditional agents actually experienced 3 crashes, while the systems with eBPF had 0 stability issues. Again, coming to the fact that it runs within the Linux kernel, it's isolated and can't affect the system. These numbers demonstrate a significant operational advantage for an eBPF approach. And as you may have guessed where this is going, Orca has developed a sensor based on that eBPF technology. Runtime visibility is now integrated into our agentless platform. It offers minimal overhead and maintenance requirements, but it provides that deep visibility into the runtime activities for those critical assets. And it's really designed to complement that agentless approach, fill in that runtime visibility gap where needed without introducing the risks and operation complexity associated with those traditional agents. So when we think about the discussion today, agentless versus agent security, the agent abyss, what is the right approach? What I believe is the optimal approach for most organizations is actually a hybrid strategy that combines the strengths of both agentless and sensor-based security. With that approach, you use agentless security for the things it's really good at, right? Broad visibility across your entire cloud estate. And then you deploy eBPF sensors for critical workloads where runtime visibility is essential. And that's a risk-appropriate security model that ensures you're applying the right level of protection to each asset based on its criticality and exposure. And let me show you this in action. If we jump back into my demo environment and go to our alerts, we can take a look at the Orca sensor. So right here within my alerts, I'm also going to see alerts that are from the runtime. Okay, so we've got malware executed alert here, and this is based on our sensor. It's been monitoring the runtime behavior, and we can see the process tree that led to this alert being generated. Each event that happened before the detection, and finally resulting in here XMRig being executed on the asset. We can see all of the context of the asset as well because we're combining that information we get through our agentless technology. We can see this is actually an EKS cluster. It's part of the simulation namespace. This is the pod. This is the node. These are the labels. We can even see the raw data of that event for forensic investigation as well. But importantly, I have a single interface to be able to see all of this information. And additionally, I get all of the context from my cloud environment as part of that alert process, which just aids me in investigating and understanding what this threat is, where it is, and how do I contain it. Now, with our sensor, we can also contain. We have the ability to just alert or monitor an alert, and we also have the ability to terminate risky processes. We can deploy the sensor across Kubernetes environments, virtual machines, even serverless computing. So things like ECS, Fargate, as an example. You can define policies either across all cloud environments, per cloud environments, or even get more granular and do it at a namespace level or based on asset tags. And we have a wide range of detections, over 150 detections for malicious processes. So there's a lot of coverage against, for example, the attack framework to be able to secure that runtime environment. The biggest benefit here, though, is that it's leveraging that eBPF technology. We don't have the same challenges, the same limitations that we had with agents. It's very, very easy to deploy, self-updating. There's no impact to the production workload, again, because it's operating within the isolated kernel environment. And we can combine all of that information with events from the cloud provider as well, from their cloud logs, AWS, CloudTrail, from the Azure audit logs, and combine both understanding what's going on at the runtime with understanding what's actually happening in the wider cloud environment. If somebody is, accessing APIs from a malicious IP address, or there are behaviors in the environment that are not normal. They're not part of the standard baseline. They're deviations. They are suspicious and potentially malicious. Combining that information together gives us layered defense. And we don't necessarily need to deploy runtime security on every single asset. We can actually use Orca to understand and prioritize where we want to do that deployment. We have a risk score against each asset. So I might say, actually, any asset that has a risk score that is greater than 8. These are the assets that I want to deploy my sensor to. These represent the biggest risk in my environment based on everything that Orca knows about them. So one final slide from me, and that's just another customer example. This illustrates the benefits of that hybrid approach. We worked with a large organization. They had strict security requirements across their environment. They were previously using multiple agent-based security tools, but were experiencing performance issues and incomplete coverage. They implemented Orca's agentless first approach with a targeted sensor deployment just for the most critical applications. So they managed to achieve 100% visibility in 24 hours across every cloud environment. They used that agentless visibility and context to understand which assets were at risk, public facing with exploitable vulnerabilities that they couldn't address immediately. And then they targeted those assets with a sensor to layer on security. They actually had a 95% reduction in the alerts they were managing because of our contextual prioritization and our reachability as well, which is using the sensor to understand if packages are actually being used by the application, if they're in RAM. They also achieved 1.8 million in cost savings from things like licensing and operational costs, and they rolled out with zero performance impact on their applications. Before we wrap up today, I'll give you an opportunity to ask some questions. If there are any questions that you have, please feel free to post them in the chat, and I'll do my best to to address them. So we've had a question. Don't I need agents for compliance reasons? And that's actually a really good question. It's come up a couple of times for me. Um, the reality is that most compliance requirements focus on outcomes, not methods. They specify what you need to accomplish, not how you accomplish it. So agentless approaches can achieve the same outcomes and typically more efficiently for most requirements. Things like asset inventory, vulnerability management, configuration assessment, access control analysis, and data protection as well. And another question there, will agentless miss threats that agents would catch? That is a valid concern, particularly for runtime threats. Agentless approaches rely on cloud APIs, right? And point-in-time snapshots to analyze that block storage. So yes, it may miss certain type of attacks that occur in runtime. That said, especially in the cloud, agents may also miss attacks. I think most organizations only get around 60% coverage with agents in the cloud. I've not worked with a single organization that has an agent deployed on every possible workload. It's very difficult to achieve. So the best approach is combining both, right? Agentless scanning to get the visibility, and then eBPF sensors, so you know what is out there, you know what at-risk assets you have, and then you can layer that security on to ensure they're protected based on the risk associated with that asset. Okay, I'm conscious of time. I think we've got 2 minutes left, so we should wrap up there. Thank you all for your time and attention today. If you'd like help evaluating your visibility in the cloud, please reach out to Core to Cloud for a free cloud risk assessment. We can provide a visibility report, a risk assessment, prioritization, and recommendations, all specific to your environment. And of course, we'd be happy to provide personalized demonstrations of the Orca platform, again, customized to your environment and focused on your priority use cases. Please also feel free to connect with me on LinkedIn and reach out if you have any questions. Thank you all.